Hello and welcome to Sleepy Scientist. I'm glad you're here, whether you've had a long day, a busy mind, or you simply love falling asleep to the sound of science. Tonight we drift upward into the secret life of clouds and the science of rain. As you settle in, let your thoughts become soft and hazy, like the sky before a gentle shower. Overhead, clouds gather silently spun from vapor and invisible breath moving with the rhythm of the wind. We'll follow their journey from nothing into something tiny, suspended, delicate yet powerful enough to shape weather-wash mountains and whisper across oceans. If you enjoy these sleepy explorations, I'd be so grateful if you gave the video a little like and tap that subscribe button. It helps more sleepy scientists like you find their way here, and it means I can keep making more of these journeys for you now. Now let's begin high above where the clouds begin, as invisible wanderers. It all starts with water, but not in the way you normally see it. Up here, far above your head, water begins as a gas drifting through the sky, as vapor unseen and unfelt. The air is full of it, even when the sky looks perfectly clear. Like secrets whispered between molecules, moisture is always there moving, quietly, waiting. Now imagine you're floating gently at tree height, your body as light as a feather. You feel the breeze lift around you, and with it something else, warm air quietly rising. As the sun touches the ground, it warms the earth, and the earth breathes upward. This rising air carries invisible water vapor, like a balloon might carry a whisper, delicate, effortless, rising higher and higher. The sky feels still, but it isn't. It's always breathing. And as the warm air lifts, it cools. Not sharply, but gradually, like tea cooling in a mug on a quiet morning. The higher it goes, the cooler it gets. You might wonder what happens to that water vapor when the temperature drops. The answer is one of nature's gentlest tricks. The vapor begins to condense. It clings to anything it can find, tiny specks of dust salt from the sea, even pollen floating miles from the forest. These microscopic particles are like little invitations saying, "Here, settle here." And when vapor condenses, something new begins to form, tiny water droplets, too small to fall, too light to sink, suspended in midair. A single droplet is barely wider than a human hair, but millions of them together. That's your cloud. So before there's anything fluffy or gray in the sky, there's this invisible water, drifting quietly, gathering around the tiniest seeds of matter. Have you ever wondered how much water floats above you on a calm day? Think about this. The average fluffy cumulus cloud, those soft cotton ball clouds, can carry up to 500,000 kilograms of water. That's the weight of 100 elephants, just floating overhead. And yet the sky doesn't seem burdened at all. Now ask yourself, why don't these clouds fall? Why does the sky hold on to them so delicately? We'll get to that soon. But for now, return to that first image, a clear sky filled with invisible travelers. They float between sunbeams, drift on updrafts, invisible but ever present. They're the beginning of something you feel often, but rarely notice: the slow orchestration of moisture into form. The next time you're outside, look up at a perfectly blue sky and ask yourself, how much water is hiding up there? What's gathering in silence above me, just waiting for the right moment to become a cloud? The truth is, the sky above you is never empty. Even now it's quietly preparing for its next masterpiece. High above your head, where the air turns thin and cool, clouds are assembling their first pieces. But they can't do it alone. They need a little help. And the help comes from some of the tiniest, most overlooked wanderers on Earth. Tiny particles far too small to see, but absolutely essential to the birth of every cloud. These are called cloud condensation nuclei. A fancy name maybe, but imagine them as the matchstick that helps light the candle, or the seed from which a whole tree might grow. Without them, the invisible water vapor we talked about earlier would drift forever, with nowhere to land, no hand to hold. You might wonder, what are these particles made of? They're a lovely mix, actually. Some are dust blown in from dry deserts, tiny flakes of forgotten rocks sent sailing across continents. Some are specks of salt tossed up from the ocean, whipped into the air by crashing waves. Others are fragments of ash from volcanoes, bits of soot from forest fires, even tiny pollen grains or bacteria drifting high above the trees. Yes, even microbes can become cloud makers. They're so small that 10,000 could sit comfortably on the head of a pin. Yet each one has a secret talent attracting water. They draw vapor toward them like magnets, offering a surface where the vapor can cool and condense. One drop, then another, and another. Soon, millions. It's strange to think, isn't it, that a vast billowing cloud painted across the sky might owe its existence to a fleck of ash or a grain of desert sand. The sky, in a sense, is always recycling the Earth's forgotten bits. And here's something cozy to consider. Without this humble dust, there would be no rain, no soft patter on rooftops, no green growing in spring, no snowflakes kissing your eyelashes. Just dry skies forever waiting. You might ask, could we have clouds in a world without dirt? Could we sculpt weather from pure, clean air? The answer is no, not without these seeds. Even inside laboratories, when scientists try to make artificial clouds in sealed chambers, they must add particles to get the water vapor to condense. No matter how advanced the science becomes, it always begins with something very old, very small, and very earthy. So next time you sneeze from dust or wipe grit from a windowsill, take a moment to marvel. Some of that stuff, those discarded particles, might be cloud makers on a different day. Now close your eyes for a moment and picture this. You're a speck of sea salt flung into the air by a crashing wave. You rise floating with the wind, catching the sun on your crystalline sides. Slowly, moisture begins to cling to you. First a film, then droplets. You're getting heavy, but not too heavy. Around you, others are forming too. You feel less alone, part of something larger. A cloud is being born, and you tiny thing, are its heart. Isn't it beautiful that every great soft shape we see in the sky begins this way, with chaos, dust, and the pull of water? The sky is a collector, and the clouds are its way of turning leftovers into something poetic. So ask yourself, the next time you see a fluffy cumulus or a delicate cirrus, what tiny things started this? Where did it come from? Whose sneeze, whose storm, whose salty wave helped build what now drifts above me? Because the sky never creates from nothing. It borrows, it gathers, it remembers. Now that the sky has gathered its tiny seeds, the next chapter of the cloud's quiet story begins. You might imagine it as a slow inhale, a rising breath from the earth itself. Warm air full of invisible vapor and dancing particles begins to drift upward. But why does the air rise? It's all about heat. When sunlight touches the ground, fields, rooftops, mountainsides, it warms the surface. That warmth radiates back into the air just above it, and as the air heats up, it becomes lighter. Like a balloon slipping from your fingers, it begins to float. This rising is gentle, often unnoticed, but it's happening all the time. And it's the start of something soft and beautiful. You can picture the air lifting, as if it's being carried on the back of a lazy dragon. Wings spread wide, catching every thermal draft. As it climbs, it carries water vapor higher and higher, away from the warm earth and into the cooler reaches of the atmosphere. Now ask yourself this. What happens when warm, wet air suddenly finds itself in a cold place? The air cools as it rises about 6.5 degrees C for every kilometer it climbs. This is called the lapse rate, but don't worry about the term. Just feel it. Imagine walking up a mountain. You start in spring and end in winter. The same thing happens to the air. And when the temperature drops low enough, that water vapor begins to condense. Think of the air like a sponge. Warm air can hold more moisture. Its pores are wide open, thirsty. But as it cools, the sponge tightens. Its capacity shrinks. It can no longer hold the same amount of vapor. Something must give. So the water condenses into tiny droplets, clinging to the waiting dust and salt particles. A cloud is forming gently, quietly, without fanfare. You can't hear it happen. You can't smell it. But up above the sky is stitching itself a new garment, one puff at a time. This whole process is called convection, and it happens every day, all over the world. Over jungles, cities, lakes, even deserts. Some of the most powerful storms begin this way, with a patch of warm earth and a column of rising air. And here's a curious question for you to hold in your mind. If warm air rises, does cold air sink? The answer is yes, and it creates a cycle. Warm air rises, cools, and sinks, again elsewhere, making vast invisible rivers of air flowing between sky and earth. It's like the atmosphere is constantly folding and unfolding itself, smoothing out creases, whispering warmth and coolness from place to place. Imagine yourself as a droplet newly born in this gentle lift. You're light, almost weightless, suspended with thousands of others. Around you, the air swirls quietly. There's no wind up here, just movement like a soft tide. You're caught in the breath of the planet. You're not raining yet. You're just floating. Isn't that a lovely place to be held in balance, on the edge of becoming not yet pulled down by gravity? Clouds that form through rising air often have that soft, cottony look. Those are cumulus clouds. Fluffy, sunlit, a bit like whipped cream. They mark places where the earth is warmest below. They are the sky's reply to the land's heat. But sometimes the rising is so slow, so delicate, that the clouds become thin, high veils. These are cirrus clouds made of ice crystals instead of water droplets, living where the air is frigid and the sun always feels far away. And on other days, the air doesn't rise quickly. It glides upward gently over hills or coastal breezes. That's when you get those low, blanket-like stratus clouds, gray and moody content, to stretch across the sky like a giant exhale. You may never see the moment a cloud forms. It happens so quietly. But now you know. Every time the air warms and rises, the sky readies its brushes. The next time you feel a sudden gust of warm wind across your face, ask yourself, where is this air going? Is it rising? Cooling is a cloud, about to be born from this breath. The sky is always building, painting, dreaming, drop by drop. Now that you've floated with the rising air and felt the moment a cloud takes its first breath, it's time to meet the clouds themselves. Not as distant scientific categories, but as personalities, as members of a great, drifting family tree in the sky. Imagine you're lying on your back in a wide field, the kind that smells like wild grass and sunlight. Above you, clouds are wandering by, each one with its own face, its own story. Let's start with the cumulus, the cheerful child of the sky. They puff and bounce like cotton balls fresh from the dryer. Short-lived, full of bounce and sunlight, they're usually a sign of fair weather. But don't be fooled. If they gather together and grow tall enough, they can turn stormy and loud. Then there are the stratus clouds, the quiet introverts of the atmosphere. They don't soar, they spread. They hang low like a gray blanket gently pressed over the land. You've seen them on days when the sky looks flat and soft, when the light becomes a whisper and the shadows fade. Some people call these clouds gloomy, but there's a softness to their stillness. There the skies sigh. Next, high above them, both drift the cirrus clouds. Thin, wispy, and graceful, they live in the upper reaches of the troposphere, where the air is ice cold. Cirrus clouds are made not of water droplets, but of tiny ice crystals. They stretch across the sky like the feathers of a sleeping bird. When you see them, you're watching the high sky speak in a hush. And then there's the towering cumulonimbus, the dramatic uncle in the family reunion. Big, moody, full of sudden outbursts. These clouds are storms waiting to happen. They rise in thick, boiling columns, often tens of kilometers high. At the top, they flatten into an anvil shape, as if pressing against the ceiling of the sky. Thunder, lightning downpours, they live inside these giants. You might ask, what makes one cloud stay low and soft while another climbs into a thunderhead? It all comes down to three things: temperature, humidity, and wind. Like ingredients in a recipe, when combined just right, they decide whether the sky bakes up a gentle drizzle or a roaring storm. The more heat and moisture available, the more powerful the cloud can grow. And wind it shapes stretches, and sometimes tears clouds apart. But the sky doesn't stop with just these four. There are dozens of variations like altocumulus, which look like fish scales scattered across a blue sea, or nimbostratus, the weepy ones bringing long steady rains with no drama. Now imagine you're floating through this family gathering. Each cloud greets you as you pass, offering its story. "Look at me," says the cumulus. "I grew from a sunny patch of field below. See how I billow and curl." "Don't forget me," hums the stratus. "I cover cities in silence. I turn sunlight into shadow, and the world grows quiet under my touch. I fly highest whispers, the cirrus brushing your cheeks with frost. I've seen stars before sunset." And then a rumble shakes the sky, and cumulonimbus booms. I carry the storm and the flash. Don't come too close. Each cloud is shaped by its journey. Some rise quickly, some spread slowly. Some are born from oceans, others from deserts. Some evaporate in minutes. Others linger for hours or even days. Have you ever stared up and wondered, why is that one cloud shaped like a ship, a dragon, a rabbit mid-leap? That's the playful side of science. Clouds are sculpted by temperature, layers, winds, and air pressure. But to you, they are also messengers of imagination. The sky invites you to guess, to dream, to see what you want to see. There's no right answer, only wonder. Now picture all the clouds you've seen this week. Think back, were they high and lacy, low and thick? Did they glow pink at sunset or turn gold at dawn? Did they chase each other or hang still like a painting? The sky is never empty. It is always writing a story in vapor and light. And every cloud, no matter its size or shape, is a sentence in that slow drifting poem. So the next time you look up, don't just see clouds. Say hello to old friends. By now you've met the cloud family, puffy, stretched, towering, and lacy. But even knowing all their names and shapes doesn't answer one of the most quietly astonishing questions in the sky. How does a cloud hold a river in the air? It's true. That fluffy cumulus drifting above your house on a summer afternoon can carry up to 500,000 kilograms of water. 500,000 liters. Enough to fill an Olympic swimming pool. And it floats there weightless, in appearance, unhurried in motion, barely making a sound. So how? To understand that, imagine yourself once again inside a cloud, not beneath it, not looking up, but truly inside. All around you are microscopic droplets of water, each one clinging to a nucleus of dust or salt, each so small that thousands could nestle on the tip of your eyelash. They hover suspended in air that supports them like a gentle tide supports leaves. You can reach out and feel them, not as wet exactly, but as a cool dampness, a mist that kisses your skin without falling. These droplets are incredibly light. A typical one has a diameter of just 10 microns, about 1/10 the width of a human hair. At this scale, gravity is a whisper, the air's resistance. The drag that slows falling objects is strong enough to keep them suspended. They fall, yes, but slowly. A raindrop might fall at 5 meters per second. But these, they drift downward at 0.01 meters per second, about the speed of a feather in syrup. They're falling, just very, very slowly. But here's the thing, they're also constantly evaporating and condensing again in a delicate balance. You might imagine each droplet like a dancer, spinning in place, shrinking, growing, merging, vanishing, reappearing. It's not a static thing. A cloud is a living, breathing collection of motion. A liquid ballet, if you will. Now ask yourself, what keeps the whole cloud from just dropping all that water at once? The answer lies in the balance between updrafts and droplet size. Updrafts, those rising currents of warm air we talked about earlier, are like invisible elevators inside the cloud. They gently lift the tiny droplets upward, countering the slow pull of gravity. As long as the air continues to rise and the droplets stay small, the cloud remains afloat. Held between forces like a soap bubble caught between two hands. But once droplets grow large enough, usually through collision and coalescence, where they bump into each other and stick, they begin to fall faster. If too many grow heavy at once, and the rising air can't hold them anymore, that's when it rains. So inside every cloud, a quiet negotiation is happening: rise or fall, hold or release. Some clouds win the balance and stay aloft for hours, never raining at all. Others tip the scale in minutes, spilling sudden showers across fields and cities. A cloud might begin its life sunny and fluffy, and within an hour darken and weep. But even as a cloud begins to rain, much of the water never reaches the ground. In dry air, raindrops can evaporate before they land in a phenomenon called virga. From a distance, it looks like a cloud is growing ghostly, tail streaks of vapor that trail downward, then vanish. There's a quiet melancholy in that isn't there rain that tries but never arrives. A promise that fades before it's kept. You might wonder how many clouds pass above you each year without ever releasing a drop. The answer is many, most, in fact. The sky is full of patient clouds, content to hold their rivers aloft, drifting between sunlight and silence. And that's part of the wonder, that something as heavy as water can be carried by something as light as air. That the sky, with all its space, can cradle lakes and streams without spilling. So next time you look up and see a cloud, especially one that looks full and soft, ask yourself, what's inside that sky bundle? How much water is it holding right now? And what delicate balance keeps it from falling? Because every cloud you see is a question the atmosphere is still answering. Now that you understand how a cloud holds so much water, without letting go, it's time to follow a single droplet on its descent, its slow, spiraling journey from invisible vapor to a soft splash on your windowsill. Have you ever watched rain and wondered why are some drops fat and splattery while others are fine and misty? Why does drizzle feel like a whisper and summer rain like a drumbeat? Let's shrink you down again, impossibly small, tucked into the vapor inside a cloud. Around you, trillions of water molecules are moving, vibrating, colliding. They're restless. Each one hopes to gather enough neighbors to make the leap from gas to liquid. And once they do, they become a droplet. Your droplet begins tiny, barely 10 microns across, smaller than a dust mite. Too small to fall, really. It floats bounced upward by the smallest breeze, its weight too light for gravity to claim. But clouds are busy places, and droplets are social. Your little drop bumps into another, then another. Each collision makes it just a bit bigger. This process is called coalescence, and it's kind of like making a snowball, gathering, pressing, growing. When your drop reaches about 0.5 millimeters wide, gravity begins to tug harder. It starts to fall slowly, at first, then faster. As it falls, it keeps meeting more droplets, and sometimes it swallows them whole. It can grow up to 2 to 3 millimeters, maybe even larger, in a strong storm, but it's not a perfect sphere as we often imagine. Big raindrops flatten into the shape of tiny hamburger buns, rounded on top, squashed underneath, thanks to the pressure of air as they fall. And here's something you might not expect. If a raindrop grows too large, say, bigger than 4 millimeters, it becomes unstable. It wobbles, flattens, and eventually splits apart mid-air, breaking into smaller drops. That's why you never see a raindrop the size of a marble. The sky has its limits. Now ask yourself this: how far does a raindrop fall? How long does it take? Let's say your droplet begins its descent from the bottom of a typical rain cloud, around 2,000 meters above ground. A medium-sized raindrop falls at roughly 5 meters per second, which means it could take about 7 minutes to reach the ground, assuming it doesn't evaporate or change along the way. 7 minutes of free fall passing through warmer and drier layers of air, dancing on the breeze pulled ever downward. But not all rain is so direct. Sometimes wind pushes drops sideways. Some are caught in thermal updrafts and lifted back into the cloud before falling again. Others evaporate mid-fall, becoming vapor once more before they ever touch the earth. A single drop might be born, fall, rise again, and fall once more before it ever lands. You've heard of the water cycle. This is its heartbeat. And then finally, your droplet makes it to the ground. Maybe it taps against a window. Maybe it lands on a leaf and rolls slowly down its spine. Maybe it sinks into thirsty soil or slips down a rooftop gutter. Its journey ends not with a splash, but with quiet purpose. Each drop is a messenger. It brings with it the sky's memory of where it formed, how it grew, what it passed through. Some carry nitrogen, a quiet fertilizer from lightning above. Others hold trace minerals collected from the sea. Even the shape of the drop changes depending on wind speed, pressure, and temperature. That's why no two rainfalls feel exactly the same. Have you ever felt summer rain that felt warm, like skin meeting skin? Or winter rain, sharp and brisk, like tapping fingers on your coat? Have you noticed how city rain smells different than country rain? It's not just imagination, it's chemistry, it's distance, it's story. So next time it rains, ask yourself, how old is this drop? Did it fall straight from a quiet cumulus, or was it shaped by lightning and wind? How many other drops did it meet along the way? Because every raindrop has a path, and if you could trace it from vapor to splash, you'd see a story as winding and wondrous as any river on earth. By now you've drifted through gentle clouds, watched droplets grow, and followed them down to the earth. But sometimes the sky doesn't stay gentle. Sometimes the calm turns heavy, and a quiet cloud starts reaching higher, darker, louder. You're about to meet the most dramatic character in the sky, the cumulonimbus, the storm bearer. It begins innocently enough, just a rising pocket of warm, moist air, like we've seen before. But instead of stopping when it meets a cool layer, it keeps going. The air is unstable, like a shaken soda can, energy wants out. The warm air rockets upward, pulling moisture with it, building a tower in the sky. Up and up it goes, through the troposphere, climbing as high as 12 to 20 kilometers, almost touching the stratosphere. The air near the top is bitterly cold, around 50 degrees C, and here our raindrops freeze into ice crystals and hail. But the updraft is still strong, still lifting, still pushing the cloud into a vertical giant. If you were inside, it would be like riding an elevator with no walls swept upward at 100 kilometers per hour, then dropped again in dizzying drafts. Inside these clouds, chaos reigns. Water droplets and ice crystals smash into each other, creating static electricity. The cloud is building a charge like rubbing a balloon on your hair. You might ask, how does that charge become lightning? Picture the cloud as a giant battery. The top becomes positively charged, the bottom negative. The ground beneath the cloud starts to respond, gathering positive charge at the surface, on trees, buildings, even on you. The tension crackles, and then snap. Lightning is the sky's release. A bolt of pure electricity, hotter than the surface of the sun, up to 30,000 degrees C, tears through the sky. The heat causes the air to expand rapidly, and that's what makes thunder the sound of air slamming back together after being violently pushed apart. But don't worry, we're watching from a distance. You're safe here, warm and dry, listening to the science hum behind the storm. Cumulonimbus clouds can stretch sideways too, their tops flattening into an anvil shape as they slam into the upper boundary of the troposphere. That shape tells pilots to stay away. It means turbulence hail, and winds strong enough to rattle even a steel-winged plane. Inside, you'll find hailstones forming, growing larger as they're tossed up and down in the cloud, adding new layers of ice with each pass. Some can grow to the size of golf balls, even grapefruits, though mercifully rare. These clouds don't just make thunderstorms. In the right conditions, they can spawn tornadoes, birthed from rotating updrafts called mesocyclones. That's when the sky stops whispering and begins to roar. But for now, let's stay soft and sleepy. Even the fiercest cloud can be watched with calm awe from afar. You might ask yourself, what would it feel like to ride inside a thundercloud, to be a droplet spun and hurled and frozen and shocked? It's a wild ride up there. But even in the chaos, nature is following rules. Physics playing its dramatic symphony. Every boom and flash has a cause, a rhythm, a story. And not all cumulonimbus clouds are loud. Some whisper rain across fields, some drop sudden hail on hot sidewalks. Others light up the night with silent heat. Lightning flashes without sound, painting clouds like slow fireworks. Storm clouds aren't villains. They're necessary. They break the heat, nourish the land, stir the air. They bring endings and beginnings. So the next time thunder rumbles from afar, ask yourself, what forces are dancing inside that tower of sky? How high does it stretch? How fast does it breathe? And above all, what beautiful balance will the sky return to once it's had its dramatic moment? Because even the loudest clouds don't stay forever. After the storm, the sky exhales, and silence returns. The rain is falling now. Not a storm this time, just a soft, steady shower, the kind that gently taps the roof and plays a lullaby on your window pane. There's something comforting about the sound, isn't there, like a heartbeat from the sky. Let's slow everything down. Let's follow a raindrop, not as it falls, but as it lands. Because rain's story doesn't end when it hits the ground. In many ways, that's when its purpose truly begins. Imagine the first drop landing on a thirsty leaf. The water rolls down its waxy surface like a traveler looking for a place to rest. It gathers at the tip, forms a trembling globe, and then falls again, this time to the soil below. Or maybe it lands on your skin. Cool, round, and curious, it clings for a moment before slipping away. Some people love the feel of rain, others rush to get inside. But rain doesn't mind. It touches everyone the same with gentle, equal care. Now close your eyes and imagine you're lying in a forest, warm beneath the canopy. The rain is falling through the branches in a rhythm as old as time. Each drop finds its way down through moss bark and fallen leaves seeping into roots. Waking seeds stirring up life hidden beneath the soil. Rain is the sky giving something back. It brings more than moisture. It carries nutrients absorbed from dust and particles in the atmosphere, nitrates ammonia, and trace minerals that fertilize. Plants feed fungi, nourish the invisible world beneath your feet. Have you ever walked outside after a long dry spell and smelled something earthy, rich, and sweet? That's petrichor, the scent released when rain kisses dry soil. It's made by plant oils and a bacterium called actinomycetes, which quietly wait in the dust until the first raindrops wake them. It's the smell of rain's homecoming. And now, picture rain landing on a river, a lake, a sea. Each drop sends ripples across the surface, tiny echoes that vanish almost as fast as they form. The rain becomes part of a larger whole. It merges with the water it once rose from. The cycle completes. You might wonder, where does the rain go once it soaks into the ground? It travels slowly. Sometimes it sinks into aquifers, ancient underground lakes, stored for decades or even centuries. Other times it begins a journey across rocks and roots joining creeks and streams heading toward the sea. Some of it evaporates again, climbing back to the sky where its journey began. It's a quiet migration, the sky to the leaf to the soil to the stream to the river, and eventually back to the clouds. And rain is more than water, it's memory. A single drop could carry particles from a distant desert salt, from an old ocean pollen, from a pine forest. Each one is a little story rewritten by time and wind. Some cultures have names for different kinds of rain. There's the soft mizzle in the British Isles, like fog made liquid. In Japan, kisame is rain that falls so gently you barely hear it. In India, the first monsoon rains are called prema varsha, or love rain bringing joy after heat. Rain shapes how we live. It determines crops, seasons, moods. In some places, children dance to call it. In others, prayers are whispered when it falls. In deserts, people listen for it like a song. In rainforests, it is a constant companion. You might ask, does the earth sigh with relief when it rains? Do plants listen for the first drop? Science tells us yes, in a way. Stomata, the tiny pores on leaves open wide to absorb moisture. Soil organisms awaken, roots stretch out. Even human hearts slow, soothed by the rhythmic pattern of falling water. Because rain isn't just weather, it's a balm. So next time it rains, don't just watch it, listen. Smell it. Step into it if you can. Let a drop land on your palm and imagine its path from vapor to cloud to you. You're part of the cycle now, too. As rain gently nourishes the earth below the clouds, that bring it also shape the world above more than you might guess. You see, clouds aren't just pretty decorations in the sky or bringers of weather. They're guardians of temperature, regulators of heat and quiet, sculptors of climate. Imagine the earth without clouds, bare, exposed, with nothing between the surface and the full searing gaze of the sun. Without clouds, the planet would overheat by day and freeze by night. But because clouds exist, the atmosphere breathes more gently, more evenly. Let's break it down. During the day, clouds act like a mirror. They reflect sunlight, specifically shortwave radiation, back into space. This is known as the albedo effect, and it helps keep Earth cooler. Bright white clouds, especially thick ones like stratus or cumulonimbus, reflect up to 90% of incoming sunlight. It's as if the planet pulls on a shade when things get too bright. But at night, the clouds change roles. They become a blanket instead of a mirror, trapping the Earth's own warmth, long-wave infrared radiation, and keeping it from escaping into space. You've felt this on cool evenings. Cloudy nights stay warmer than clear ones. That's the clouds at work, tucking the planet in. So clouds cool and warm us often within the same day. But their effect isn't always balanced. Some clouds warm more than they cool. Others do the opposite. High, thin cirrus clouds let sunlight through, but trap heat below, acting like a greenhouse. Low, thick clouds reflect a lot of light, cooling the surface beneath. It all depends on altitude, thickness, and coverage, a quiet dance of light and shadow. You might wonder how much of the Earth is covered by clouds at any given moment. On average, about 2/3 of the planet is under cloud cover. That means at any moment, billions of tiny droplets are shaping the climate unseen and mostly unappreciated. And clouds don't work alone. They interact with aerosols, tiny particles in the air that can either help clouds form or change how much sunlight they reflect. Some human-made aerosols, like sulfates, can brighten clouds and cool the Earth. Others, like black carbon, absorb heat and warm the atmosphere. This is where science gets both fascinating and delicate. Because as the planet warms, cloud behavior may shift. More heat can lead to more evaporation, creating more clouds, but it can also change their type, height, and timing. Some scientists worry that certain warming trends might thin out low clouds, reducing their cooling effect and allowing even more sunlight to heat the Earth. Clouds are full of mystery, even for experts. They're one of the biggest uncertainties in climate modeling. We know they matter, but predicting exactly how they'll respond to change is like trying to forecast the mood of a sky filled with millions of shifting whispers. Still, we do know this. Without clouds, Earth would be a very different place. Not just less beautiful, but less stable, less gentle. They are the Earth's soft regulators, balancing heat and cold sun, and shadow wet and dry. Imagine them now, a wide blanket of stratus clouds stretching over an ocean, reflecting sunlight, calming the waves. Or a field of altocumulus, rippling like the scales of a sleeping dragon, letting light pass through in golden threads while trapping warmth below. Clouds are always adjusting, responding, adapting. So next time you feel a sudden chill beneath a passing shadow, or notice how the world glows gold when the sun slips through a cloud, ask yourself, how many degrees has the sky just shifted? How is this drifting shape quietly protecting life below? Because clouds don't just bring rain, they bring balance. And in their quiet, floating way, they keep the planet feeling just right, day after day, breath after breath. You've seen how clouds carry water, sculpt weather, and cradle the Earth's warmth. But did you know that they also tell stories of time? Not just in the rhythm of a passing afternoon or the change of a season, but in patterns that stretch back centuries. Clouds, it turns out, are one of the sky's best storytellers. Let's begin with a question. What did the sky look like 100 years ago? No cameras, no satellites, just painters and poets and journals. But even then, clouds were being watched. Luke Howard, an amateur meteorologist in the 1800s, was among the first to classify clouds systematically. He gave them names in Latin: cumulus heap, stratus layer, cirrus curl, and nimbus rain. His simple system gave shape to something previously seen as formless. Imagine before that people saw clouds mostly as moods metaphors or messengers from gods. After Howard, they became part of science's vocabulary, observable, predictable, meaningful. But the real storytelling began with satellites. Since the 1960s, we've been taking pictures of clouds from space, millions upon millions. And from those photos, scientists can read changes in global cloud cover storm frequency and precipitation trends over decades. You might ask, what have the clouds been trying to tell us? They show that tropical cloud belts are shifting. Poleward, that high-altitude clouds are rising as the upper atmosphere warms, and that the length and timing of rainy seasons are changing. Even the height of cloud tops has crept upward in some regions. These are clues, hints that the atmosphere is slowly rearranging itself. But clouds also store shorter stories, like the passage of a single day. If you've ever watched a time lapse of clouds sped up so that minutes become seconds, you'll see them boil, stretch, dissolve, and reform. They look alive like thinking creatures mapping invisible currents above. And then there's the seasonal tale. Spring clouds rise faster and scatter quickly. Summer clouds puff up huge by afternoon, often ending in a stormy curtain call. Autumn clouds spread slow and low, full of quiet reflection. Winter clouds, especially in colder climates, hang heavy and still like wool pulled across the sky. But clouds don't just mark time, they can preserve it too. In Antarctica and Greenland, snow falls from clouds year after year, compacting into ice cores that scientists drill and study. Inside those cores are tiny bubbles, frozen pockets of ancient air. They tell us what the atmosphere was like hundreds of thousands of years ago, what gases were present, how much carbon dioxide floated above, how warm or cold the planet might have been. All from snow that began as vapor in a drifting cloud. Isn't that amazing, that the ghost of a cloud from 800,000 years ago can whisper to us through ice? Even volcanic eruptions have cloud signatures. The 1815 eruption of Mount Tambora sent ash so high into the atmosphere that it created stratospheric aerosols, spreading a global veil of cloudiness that dimmed sunlight and dropped temperatures. The year after 1816 became known as the year without a summer. Clouds marked that moment and still do today after major eruptions or wildfires. The particles thrown into the air rise, attract moisture, and form eerie, beautiful sunsets or unusual cloud shapes, painting the sky in orange and violet long after the event has passed. So next time you see a particularly strange or beautiful cloud, ask yourself, what is this one remembering? What story does it carry? What past wind or fire or flood helped shape its form? Because the sky is a library, and clouds are its books, not ones you read with your eyes alone, but with patience, with wonder, with science and stillness side by side. You are looking at a living archive drifting slowly above your head. The sky, as you now know, is never still. But among all the drifting, whispering, rain-spilling clouds, there's a secret dance taking place, one that happens above oceans, across mountains, and even in the jet stream lanes where airplanes carve their paths. It's the dance of wind and cloud, an invisible choreography that sculpts the atmosphere itself. Let's begin with a gentle question. If clouds are made of water, droplets, and air is always in motion, how do they keep their shape? Imagine a cloud as a soft balloon, not tied off but constantly filled and reformed by the air around it. It grows, stretches, spins, or dissolves, depending on how the wind behaves. Some clouds ride calmly on gentle breezes, like stratus clouds, gliding low across flat land. Others are shaped by mountains forced to rise and form lenticular clouds, those smooth, lens-shaped ones that hover like silent UFOs above peaks. You may have seen one paused in place as the wind howled around it, steady and surreal. And these lenticular clouds are born from something called orographic lift. When moist air hits a mountain, it has nowhere to go but up. It rises, cools, and forms a cloud. Then, as it flows down the other side, the cloud often disappears, evaporating like a memory mid-sentence. But there's more. Sometimes clouds align in neat rows, called cloud streets, stretching over oceans for hundreds of kilometers. They look like tire tracks in the sky. These form when cold air passes over warmer water, sparking convection in tidy lanes. The clouds form along the upward motion, and the gaps mark the sinking air in between. Even stranger are wave clouds, which undulate like ripples on a silk sheet. You'll see them when stable air flows over an obstacle, maybe a ridge or a change in terrain. The air bounces, forming rhythmic crests and troughs in the atmosphere, and clouds condense right along the wave's peak. Sometimes they stack up into Kelvin-Helmholtz waves, those fleeting clouds that look like ocean surf, curling and breaking in midair. Yes, clouds can surf the sky. You might ask yourself, how can something so soft respond to invisible forces with such precision? It's because clouds are tracers. They reveal what the wind is doing, even when we can't feel it from the ground. Meteorologists often study clouds to understand wind shear turbulence or the presence of jet streams, those narrow, fast-moving rivers of air high above the earth. The jet streams don't just move clouds, they can create them. When a plane flies through the upper atmosphere, the moisture in its exhaust may condense and form contrails, those long, narrow streaks that follow aircraft across the sky. Under the right conditions, they linger for hours, widening into broad cirrus-like veils. In fact, contrails are so common now that they've subtly changed how much sunlight the Earth reflects and traps, especially in busy air corridors. It's a quiet example of how even our fastest, most fleeting machines leave a mark on the sky. But not all air movements are caused by mountains or machines. Sometimes the atmosphere generates its own internal waves, known as gravity waves. Not the space kind, but atmospheric ones, when a parcel of air is displaced and bobs up and down like a buoy in water. These can form bands of clouds, stacked like fingerprints, slowly drifting in unison. So when you look up and see regular patterns in the sky, rose curls, stripes, you're not just seeing clouds. You're seeing the motion of air made visible. And motion matters. Clouds formed in turbulent winds often grow uneven, fall faster, or spark thunderstorms. Calm, layered clouds signal stability, a sleepy atmosphere barely stirring. In this way, the shape and movement of clouds offer hints about what's to come, a soft clue from the future, written in vapor. Have you ever stood still and watched clouds change shape in real time? If not, try it. Give the sky your stillness, and it will offer you movement. Watch as one cloud stretches its fingers across the sky, only to vanish at the edges. Or another, once whole, pulled thin until it becomes a ghost. Or a tiny puff growing fat and full, its belly rounded with moisture. Each one is telling you how the air moves. So next time you feel a breeze and look up, ask yourself, where has this wind been? What stories has it whispered to the clouds? What shapes has it carved from water and sky? Because every breeze writes a sentence, and clouds are the quiet readers drifting by. By now you've seen clouds as travelers, storytellers, guardians, and even dancers. But did you know that clouds have a nightlife too? Not just the ones that flash with lightning or darken the sky before a storm, but the ones that glow with moonlight, shimmer with mystery, or drift so high and faint you can only see them after sunset. Tonight, we turn to the sky's quietest and most secretive residents, noctilucent clouds and their twilight kin. Close your eyes and imagine a deep blue summer night, the kind where the sun has just dipped below the horizon, but the sky still holds a trace of gold. The stars begin to appear, but wait. Something else is glowing in the north. There, just above the curve of the earth, you see something delicate. Threads of silver blue light, glowing like frost, lit from within. They move slowly, rippling like satin, far higher than any other cloud. These are noctilucent clouds, meaning night-shining clouds, and they are the highest clouds in Earth's atmosphere, forming in the mesosphere around 80 kilometers above the ground. That's 4 times higher than cirrus clouds and high enough to touch the edge of space. Unlike regular clouds, noctilucent clouds are made not from water droplets, but from tiny ice crystals that form on microscopic dust, sometimes from meteor trails. They are so rare and so faint that they can only be seen during astronomical twilight, when the sun is just low enough to light them from below, but not the sky around them. And they're seasonal too, most visible in late spring and early summer, especially at high latitudes near the Arctic and Antarctic circles. You might ask, why do they glow? It's all about angle and altitude. When the sun is far below the horizon, it can still light the upper atmosphere. The lower sky is already dark, but the mesosphere is catching the sun's last rays. Noctilucent clouds reflect that hidden sunlight, making them visible in contrast to the night. They are faint, ephemeral, and eerily beautiful. Some scientists believe that noctilucent clouds are becoming more common, possibly due to climate change or the increasing presence of methane, which breaks down in the upper atmosphere and creates more water vapor. More vapor, more ice, more glow. But these aren't the only nighttime clouds worth watching. There are also moonlit stratus clouds, low and wide, glowing softly with reflected silver. These are the clouds that roll in after sunset and turn the world into a dream. The moon shines through them, haloed in mist, making shadows gentle and strange. And then on crisp, clear nights, you might see cirrostratus clouds so thin and high you hardly notice them until they catch the light of the moon and form a lunar halo, a perfect ring of pale light, usually 22 degrees wide, surrounding the moon like a crown. These halos happen when moonlight passes through ice crystals, bending at just the right angle to form a circle. You've probably seen one before, maybe even made a wish on it, without knowing the quiet geometry behind it. But not all nighttime clouds are visible. Some simply change the way the night feels. They muffle city lights, soften starlight, and add a weight to the air. When fog rolls in after dark, it's like the world is being gently erased. Trees become silhouettes. Sounds grow quieter. Light diffuses into a glowing hush. Have you ever taken a walk on a foggy night? There's something oddly cozy about it, like the world is wrapping itself in a sky-made blanket. And in these clouds, seen or unseen, there is comfort. Because even when the sun is gone, the sky is still at work. Clouds still breathe, still reflect, still shape the air above you. They just do it more softly, more secretively. So next time you step outside at night, pause and look up. Ask yourself, is that silver glow a cloud catching moonlight? Are those faint streaks a message from the mesosphere? Is the night sky truly empty? Or is it just whispering in a different light? Because clouds don't sleep, they just change their voice. And when the world is quietest, they speak the loudest, if you know how to listen. With the stars above and the clouds softly whispering their twilight secrets, let's turn our gaze from the skies, back to the ground, to something far more intimate. Have you ever walked outside on a chilly morning and found the world draped in a blanket of mist? The way it clings to the grass, curls around lampposts, and makes everything quieter than it was the night before. Tonight we step into the gentle, earth-bound cousin of cloud's fog. Yes, fog is a cloud, just a very low one. It forms right at ground level, so instead of looking up to see it, you walk right into it. And the experience is different. Clouds from below are untouchable, high and distant. But fog greets you on your doorstep. It wraps around your ankles, climbs past your shoulders, muffles your footsteps. You don't just watch fog, you feel it. So how does it form? Fog begins the same way clouds do. Moist air cools, and water vapor condenses into tiny droplets. But for fog to form, the air has to cool very close to the ground, often overnight, when the warmth of the day slips away and the surface cools quickly. There are a few kinds of fog, each with its own sleepy charm. There's radiation fog, which forms on calm, clear nights when the Earth radiates heat into space. Without wind to stir the air, a thin, dense fog forms, especially in valleys where cold air gathers like water in a bowl. There's advection fog, created when warm, moist air slides over cooler ground or water. This is the kind that rolls off the ocean and drapes itself over cities like San Francisco, slowly swallowing skylines and steeples until only outlines remain. And then there's evaporation fog, a beautiful paradox where cold air moves over warm water and steam rises to meet it. On cold mornings near lakes and rivers, you've probably seen this fog swirl like breath from the mouth of the earth. It's fog with a little drama, fog that wants to dance. You might ask, what makes fog feel so different from rain or cloud? It's partly sensory. Fog changes the way sound moves. It dampens distant noises, makes nearby ones sharper. A dripping faucet, a closing door. Everything sounds like it's happening right next to you. It also scatters light, making street lamps glow with halos and headlights stretch into soft beams. It's no wonder fog feels magical, even eerie. And then there's what fog does to time. It slows it down. Have you noticed? When you're in fog, the world seems to pause. You walk more slowly. You look more carefully. The edges blur, and your brain focuses on the near and now. It's like the sky is telling you, don't rush, just be. Fog is the pause between thoughts, the breath before speech. Even animals behave differently in fog. Birds call less often. Deer move more cautiously. Insects cling to leaves waiting. Nature, like us, grows still when wrapped in cloud. And fog isn't just beautiful, it's important. In some places, it's a crucial source of moisture. Along the coast of Chile and Peru, special nets called fog catchers harvest water from the air, collecting up to 10 liters a day per square meter. The water drips into troughs and is used to grow crops, feed livestock, and support life in places where rain is rare. Imagine that a cloud you can catch turning air into drinking water. Fog also plays a role in cooling ecosystems, protecting plants from drying heat and reducing evaporation. In the towering redwood forests of California, up to 40% of the tree's water intake comes from fog absorbed through leaves and bark. So the next time you wake up to a foggy morning, ask yourself, what is this mist feeding? Who is drinking from this low cloud? What quiet miracles are hidden behind the veil? Because fog isn't just a lack of clarity. It's a presence soft and patient and vital. It invites you to slow down, to feel the air against your skin, to listen more closely to the world around you. Fog isn't lost. It's just in no hurry to be seen. As you've wandered through clouds, rain mist, and moonlight, perhaps you've begun to feel just how alive the sky really is. It breathes, it remembers, it transforms. And sometimes when the light is just right and the air is just still enough, it reveals a kind of quiet artistry. Clouds shaped like dragons, oceans, feathers, or flames. Tonight, let's explore one of the most whimsical corners of meteorology, the strange and beautiful world of rare and unusual cloud formations. You might think you've seen every cloud type, fluffy cumulus, flat stratus, streaky cirrus, but the atmosphere has more surprises in store. Some clouds don't fit neatly into any box. They're sky-born sculptures, each one appearing briefly, sometimes only once in a decade, before vanishing into the wind. Take the mammatus cloud, for instance. The name comes from the Latin word for udder, which may not sound elegant, but when you see them hanging in the sky, they're mesmerizing. Round pouch-like structures dangle from the base of a thunderstorm, glowing gold or lavender in the fading light. They look like the sky has grown scales or bubble wrap or the underside of some celestial creature. Mammatus clouds often appear just after severe weather, like a sigh of relief from the atmosphere. They can stretch for miles, making the sky feel textured, heavy, but oddly peaceful. Then there's the Asperitas cloud, a recent addition to cloud classification only officially named in 2017. These look like a stormy ocean turned upside down. The clouds appear to roll and undulate in chaotic, surreal waves. If you've ever seen a painting by Van Gogh, you'll recognize the drama. These clouds don't always bring rain, but they carry a mood like a sky unsure of its own emotions. You might wonder, why do these odd clouds form? At all, the answer is usually turbulence, when different air layers collide, when temperatures shift rapidly, or when moisture surges through a previously dry space. In other words, the strange shapes are signatures of atmospheric imbalance, briefly visible before the sky finds its rhythm again. But the oddities don't stop there. Have you ever seen a cloud shaped like a roll? That's the morning glory cloud, a rare phenomenon that forms long horizontal rolls stretching hundreds of kilometers. Pilots in northern Australia actually surf these clouds in gliders, riding the air current like a wave. The morning glory is mysterious, and although it has been studied for decades, its exact cause is still debated. It's one of the sky's great unsolved riddles. Then there's the fall streak hole, sometimes called a hole punch cloud. These appear in altocumulus or cirrocumulus layers, flat clouds high in the sky, where suddenly a large circular gap opens up sometimes with a streak of ice crystals falling from the center. It looks like someone scooped a bite out of the cloud layer. These holes form when an aircraft disturbs the supercooled water droplets in the cloud, triggering freezing and causing the surrounding droplets to evaporate. The result is a perfect celestial donut, a clear patch in an otherwise unbroken sky. You might ask yourself how many people looked up that day and noticed how many caught the sky. Mid-gesture, clouds like these are reminders that the atmosphere is more than predictable cycles. It's also full of coincidence, anomalies, and art, and sometimes the clouds come to life in optical illusions. A glory, for instance, is a circle of light, often rainbow-colored, that forms around the shadow of your head when you're above a cloud layer, like on a mountaintop or in a plain. Pilots sometimes see the shadow of their aircraft surrounded by this glowing ring, floating like a halo on the mist below. Or consider cloud iridescence, where sunlight diffracts through droplets and ice crystals to create pastel hues. Mint rose lavender, soft rainbows that don't arc but shimmer across the body of a cloud like oil on water. These events are fleeting, sometimes lasting mere seconds. You have to be looking. You have to be still. So next time you glance up and see something strange in the sky, a roll, a hole, a ripple, a wave, ask yourself, what is the air trying to express right now? What invisible currents have sculpted this moment? Because in the atmosphere's quiet experiments, the ordinary becomes sublime. And perhaps the most beautiful thing is this: no two cloudscapes are ever exactly the same. Now, after all our wandering among vapor and wind through thunderheads and moonlit fog, you're gently returning to the place where clouds began. Not high in the mesosphere, not hanging over oceans or cities, but in the heart of something deeply personal, your perception. Because clouds don't just shape the weather, they shape how you see the world. Think of how often we look to the sky for signs. A clear sky for clarity, a cloudy sky for mood, a stormy sky for drama, or for permission to stay inside cozy and slow. Clouds have always mirrored our emotions. Poets have known this. Artists, too. Even children lying in fields, naming shapes in drifting cumulus dragons, castles, ships. Clouds are canvases for imagination, but they're also real physical measurable things. They have structure. They obey laws of physics. They reflect solar radiation. They transport heat and moisture. They participate in cycles that sustain life. And yet, they vanish if you try to hold them. Even with all our science, clouds remain wonderfully transient. Each one is a moment, a phase change, a whisper in the sky. And this brings us to one last wonder, how clouds may change in the future. As our climate shifts, clouds may shift too. Some models suggest a thinning of the cooling low clouds in warmer climates. Others suggest more intense cloud bursts in certain regions. Still others warn of feedback loops, where cloud behavior accelerates warming or mitigates it. It's a delicate, complicated relationship. You might ask, are the clouds of tomorrow already being shaped by today? Yes, in small ways, in patterns we're just beginning to trace. Urbanization affects cloud formation. Airplane traffic leaves persistent contrails. Agricultural dust can seed clouds in new places. Even forest fires alter the albedo of cloud systems. The atmosphere listens to all of it. But it's not just about change. It's about awareness. The more we understand clouds, the more we understand the systems that support us. Rainfall, temperature, balance, freshwater access, even food security. Clouds are connective tissue, linking oceans to forests, deserts to mountains, humans to each other. And as you've now felt, they are also deeply soothing. There's a reason so many people feel calmer on overcast days. Why we fall asleep to the sound of rain. Why children trace patterns in the sky with sleepy fingers. Clouds tell us it's okay to pause. It's okay to drift. It's okay to soften. So next time you find yourself staring up, whether it's from a plane window, a long drive, or your own backyard, pause and notice. Ask yourself, where is this cloud going? What story is it whispering? How does its presence change the world beneath it? Because clouds are always speaking. You just have to listen. They may not stay long, but their echoes linger in the soil. They water the sunlight. They filter the thoughts they stir. Let yourself drift a little now. Let your breath move like a cloud. Let the sky above soften into memory. You've walked through vapor and light, through droplets and dust, through storms and silvery calm. And now it's time to rest. Let everything begin to slow. The sky above grows dimmer, softer, quieter. The clouds you've been traveling with, the gentle ones, the towering ones, the whispering midnight ones, they're all beginning to settle now. Some dissolve into the air light as sighs. Others stretch thin across the stars, glowing faintly with moonlight. You feel the hush of a foggy morning curling around you. A sense of stillness, a weightlessness in your thoughts. Even the thundercloud, so bold and wild earlier, now rests on the far horizon, low and harmless, like a giant exhaling. The earth is quiet beneath you. The air is cool. The last drops of rain have fallen. The last questions have floated away. There's nothing more to chase, nothing left to wonder, at least for tonight. Just let the atmosphere hold you. Let your breath move slow in and out, like mist rising from a warm lake. Let the weight of your body sink gently downward as the clouds drift gently overhead. And if sleep hasn't come already, it's close now. Hovering like a cirrus cloud, soft, slow, light as air. If you've enjoyed this journey, I'd be quietly grateful if you'd give this video a like or tap that subscribe button for more peaceful explorations with the Sleepy Scientist. It helps more than you might imagine. And before you drift off, I'd still love to know, where in the world are you listening? From what time it is there? Leave a comment if you're feeling cozy enough to share. It's always a quiet joy to see this sleepy little community ripple across time zones and continents. Good night, sweet dreams.